Hakulugi, the lava, when erupted, flows down the side at a slowing rate in miles per hour. The distance, in miles or y, reaches from the crater to the tip of the lava. This is given by the equation y equals 7 times 2 minus 0.9 to the x, where x equals the time. To start off, we want to find the derivative of this function and determine its speed at 0, 1, 5, and 10 hours. Is it going faster or slower over this time period? First, we find the derivative of the inner function. Since 2 is a constant, it is eliminated and negative 0.9 to the x turns into negative 0.9 to the x times the natural log of 0.9. Using substitutions for f of x equals 1, and the equation of 7 times quantity negative 0.9 to the 1 times the natural log of 0.9 equals approximately 0.6638 miles per hour. At x equals 5, f of 5 is approximately equal to 0.4355 miles per hour. At x equals 10, f of 10 is approximately 0.2572 miles per hour. And finally, at the start, x equals 0, f of 0 is approximately 0.7375 miles per hour. Looking at these trends from 0 to 10 hours, you can see that the lava is slowing down. Our next problem involves transforming the distance equation into terms of x. To start off, we divide the 7 on both sides of the equation. Then, we isolate the constant of 2 by adding 0.9 to the x on both sides. To isolate x, y over 7 is subtracted on both sides. To get x on its own, the natural log is used for both sides, and this makes the exponent of x times the natural log of 0.9 equal the natural log quantity 2 minus y over 7. After that, the natural log of 0.9 is divided, making x equal the natural log quantity 2 minus y divided by 7 all over the natural log of 0.9.
This next problem requires differentiating the equation found previously with respect to y to create the new equation of dx over dy. After that, what is the value of dx over dy when y equals 10, and what units are they? As you recall from earlier, the value of the function is x equals 1 over the natural log of 0.9 times natural log of 2 minus y over 7. To find dx over dy, the product rule or quotient rule will not be used due to a long and complicated process. Instead, we are going to differentiate the second term of natural log of 2 minus y over 7 since a variable is located within. The derivative of a natural log of x is just 1 over x, but in this case, it is 1 over 2 minus y over 7 times the derivative within the parentheses, which will equal out to negative 1 over 7. To simplify, the value will equal negative 1 over 14 minus y. Next, we take the first term, 1 over natural log of 0.9, and multiply it by the newly differentiated term. This will equal 9.4912 over 14 minus y, and substituting 10 for y, we get the dx dy value of 2.372 units, which these units will be in hours per mile. What we are going to do is substitute 10 for x in the original equation, which is y equals 7 times 2 minus 0.9 to the x. After finding the value of y equals 11.5593, substitute this value of y in the dx dy equation. This result should end up being 3.8887 hours per mile. So you may have thought that dy over dx and dx over dy are reciprocals of each other based on the previously found answers. So how is this true in one way but also not true in the other? Looking at the previous answer of dx over dy when x equals 10, we got the equation 9.4912 over 14 minus 11.5593. The inverse of this equation will equal 0.257154 miles per hour. If you recall dy over dx being 7 times negative 0.9 to the x times the natural log of 0.9, we can substitute x for 10 and get the exact same value. In a case that isn't true, however, the reciprocal of dx over dy is not the same as dy over dx when 10 is substituted in for y, as shown in this equation below.